All right, so the 2.9 is log expressions, and this is just like scratching the surface on logs. We're literally going to cover logs into the end of Unit 2. So this little part is what will be on the test. There is one part that's calculator, if you want to get that out. Shh, you guys, zip it. So the basis of logs, and this is an algebra, definitely algebra 2 review, it is a way of rewriting an exponential function, basically. When you look at a log, the little subscript number, or the smaller number that's lower, is the base of that log. So on this would be read as log base A of x. And what you're really saying is, what power do I raise A to get it to be x? You're going to see in the beginning they are written as an equation, and you're going to convert it. So if it had said this part of the expression, the little a comes over and picks up the y and drops off, leaving the x. And I would get a to the y equals x. And then it will say, here's an exponential equation, rewrite it as log. And so you would reverse it. The base on the exponential function becomes the base on the log. These would break apart. The x comes on the side with the log, and the y goes across to the other side. If you had Miss Corey, she teaches like Bay. Yeah. If you remember Bay. I told you guys last year that I think of log, like the pairing on logs is like a high school relationship. They never stay together. And I always hurt somebody's feelings when I say it. I don't mean your relationship. I'm sure yours will last forever and ever and ever and ever and ever, but most likely not. But they don't stay together. So the pairings, whether they're together on the log side or they're together on the exponential side, they never stay on that same side. Okay, they separate. The whole thing is called a logarithmic function, but we're going to just say logs. And you're going to eventually do a lot of things with this, but today we're just going to simplify. So to go from log to exponential or exponential to log will be the first thing we're going to do. If I know 2 to the third equals 8, then I can rewrite it as log base 2 of 8 equals 3. You got to know how to go back and forth, which is the first thing. Then you get log by itself. So the word log is log base 10. They call it a common log, okay? If there is no log there, then it is base 10. The log button on your calculator is log base 10. We're going to look where the change of base is, but I'm going to show you that in a little bit. Which means if you see something like log of 10, you can rewrite this as log base 10 of 10. And you should be asking yourself, what do I raise this to get to that? And it would be to the first power. Good. If you have a log and any base here, and then it has an exponent here, then literally the exponent on it would be the answer there. So if it said log base 5 of 5 squared, then it's just 2. So that's one way to look at it. All right, we're just rewriting. So it says rewrite the log equation as exponential or vice versa. All right, so A, 4 comes over and picks up the negative 1. So 4 to the negative 1 equals 1/4, which is a true statement, right? If it's a negative 1, it moves to the bottom. And then for the second one, this is in exponential, and you want to get it into log. So the base on the exponential becomes the base on the log. These break up, so the 1/2 goes to the other side, and the 5 comes over with the 25. Do we all remember this? Yes? Okay. All right. The good news is it's mostly mental math. So for those of you that hate showing work, this is your time to shine. Okay? So those are the people that love logs the most. So log base 3 of 3 is what? 1. Log base 3 of 81. 4. Good. And that is because, and if you don't know it, you could break it down. But that is because it takes 4 3s to get 81. Log base 3 of negative 9.
Negative 2.
Not possible. Why isn't it possible? There is no power I can raise a positive number 2 to make it negative. This number can never be negative, and it cannot be 0. Okay? Has to be greater than 0. It cannot be negative, and it cannot be 0. So you would write no solution, you could do 0 with the strike through, not possible, anything like that, undefined, anything like that's good. Okay, D, log base 36 of 1/6. Good. How did you get there?
You flip it over with a negative and then square it with the negative.
Okay. So I need to move this to the bottom, right? Which means it's going to be a negative. And then, oh wait, it's not -2. It is -1/2 because you are then square rooting it, okay? If it was the other way around, if it was log base 6 of 36 or 1/36, that is -2. But if I'm going from 36 to 6, it's a square root, and a square root is 1/2. So that had two parts to it. You can also set it equal to x and say 36 to what power gives me 1/6, and you could get it to change the base. So this would be 6 to the -1, and this would be 6 to the second raised to the x. So that's the other way to do it. 2x would equal -1, and x would equal -1/2. But the goal, especially with these simpler ones, is to be able to do that in your head. All right, E, log of 1,000, 3. That is a base of 10. And when you're raising to a power with 10s, you literally just have to count the zeros. And log base 3 of 1, 0. Any base raised to the 0 power is 1. Good? Questions? All right, now we're going to do these two different ways. One, there is no power. I can raise 3. That is a whole number to get it to 17, right? So we're going to learn how to approximate this, and then we're going to actually use our calculator for it. So what if I need to put 17 in between two power products of 3? So 3 to the second is 9, and 3 to the third is 27. And 17 lies somewhere in between these, right? Is it closer to 9 or is it closer to 27?
9.
Just a little bit closer to 9, right? It's 8 away instead of 10. So we can say this would be closer to 2 than it is to 3. So we could say this is like 2.4. You're totally approximating here, okay? So you're finding what two powers it would fall between and then approximate. And they could ask you that without a calculator, so you need to know how to do that. Then it will ask you, do it with a calculator. And there are two ways to do this. One is called change of base. And the change of base says you can rewrite any log as a fraction or as a division, okay, a quotient of logs of the same base. So I can rewrite log base 3 of 17 as log of 17 over log of 3. The base goes to the bottom. I can also write it as ln's, if you remember ln's. I can also write it as ln 17 over ln 3. So you can do those in your calculator, or your graphing calculator under the math menu has a button that says log base. What? All right, so on your graphing calculator, oh, it's like I have a strobe light. On the graphing calculator, if you hit math and you go all the way down to A, it says log base. If you hit enter there, it gives you the log with the lowered base and then the number next to it. So I can rewrite that as 3 and 17 and hit enter. And I get 2.5789. So this would round to 2.579. Yep.
Can we always do it the change of base?
You sure can. Yeah, so if you forget that step or you don't have a calculator that has that button, because not all of them do, you can do log or ln. You can do log of 17. You just got to remember to close your parentheses, divided by log of 3. Or you could do ln of 17. Again, make sure you close the parentheses or make it a fraction, divided by ln. You can pick the same one. ln 3. Notice it's the same answer for all three. And there's just some application, especially when you get into your AP classroom questions. There's one about like the Richter scale, okay? A log scale is used to display numerical data over a wide range of values to make it easier to visualize or work with. So a lot of times when something is increasing in an exponential way or a huge bit, like jump between numbers, they use logarithmic scales. So the Richter scale is actually log based. It uses a base 10 to measure the earthquake, so the magnitude of 2.0 is technically 10 times more intense than a 1.0. So it'll say, it actually explains a little bit of it in your AP classroom question, but that's where you'll see these used. We're going to eventually get to something called a like semi-log plot, which basically just takes your increments and changes them on your graph, but that's like next test problem, okay? For right now, it's just a little bit of application of things like this. Easy stuff, yes? Questions?